Welcome to this Radiation Safety Awareness Training course. This is a brief course to provide an understanding of the X-ray equipment and sources of ionising radiation on site at EI Electronics. This course has been prepared by myself, Dr. Elaine Dorley of Radiation Safety Ireland. I'm an approved radiation protection expert advisor and I provide radiation protection advisory services to EI Electronics. The health and safety of all employees, contractors and visitors has always been of paramount importance at EI Electronics, and this includes ensuring safety when working with radiation sources and with X-ray machines on site. It is a legal requirement that all persons who work with such sources and with X-ray equipment have radiation safety awareness training, and this course aims to provide you with such training. So I hope you enjoy the training course, and thank you for your attention. So firstly, what is radiation? Radiation is the transmission of energy in the form of waves or particles through space or a medium. So on site at EI Electronics we have X-ray equipment, and this X-ray equipment have X-ray tubes inside them. And when the X-rays are switched on, we get these invisible waves of energy being emitted from the X-ray tube. And we can't see them, we can't smell them, we can't taste them. And that sometimes makes radiation a little bit scarier than other hazards because we've no physical means of perceiving them. Here we have the electromagnetic spectrum. All of these items here emit waves of energy at us. Over here on the right hand side of the spectrum we see household items such as radios and microwaves, and they emit out waves of energy at us. But the waves of energy emitted from these items have got a very long wavelength and very little energy in them, so they don't cause us any harm. Whereas over here on the left hand side of the spectrum you've got things like X-rays and radioactive sources that might emit gamma rays. And these items emit waves of energy that have a very short wavelength and a lot of energy in them, so they can be quite harmful. There's a cut-off point here between UV light and X-rays. The ones on the right-hand side of the spectrum are called non-ionising radiation, whereas these ones here on the left-hand side of the spectrum from X-rays upwards are classed as sources of ionising radiation. And on site at EI Electronics we have X-ray equipment, and they emit X-rays, which are short wavelength, high energy waves of energy. And if you have an X-ray machine on your site or any source of ionising radiation, you must have an authorisation from the regulatory authority. And in Ireland, the regulatory authority responsible is the Environmental Protection Agency, the EPA. And EI has a licence from the Environmental Protection Agency to have X-ray equipment on its site. So just to explain the difference between natural sources of radiation and artificial sources of radiation. Ionising radiation can be artificially produced. So for example, X-rays. So on site at EI Electronics we have X-ray equipment and they produce X-rays, but these are manufactured machines. They're artificial sources of radiation. They're not naturally occurring. But just to be aware that we are also exposed to radiation all day, every day, and this is naturally occurring radiation that's found in our environment. So for example, in soil and rocks and building materials, there are naturally occurring elements that are radioactive and that give us a dose of radiation all the time, and we can't do anything really to avoid getting some exposure to naturally occurring radiation all the time. What's a little bit more significant is if you travel on an airplane, you get about 50 times more radiation exposure than you would do at ground level, because we're exposed to cosmic rays as we travel up through the Earth's atmosphere, and the higher up we go in space, the more radiation we're exposed to there. And again, that's all naturally occurring radiation that we're exposed to. We can also be exposed to radon gas, which is a naturally occurring radioactive gas that comes up through the ground, and that can cause some radiation exposure in our homes and in our workplaces. So it's important that you test your home as well for radon gas. So these are natural sources of radiation that we're exposed to all the time. We're all getting a little dose of radiation all the time. We can't really avoid that from natural sources. but on site at EI Electronics, we also have artificial sources of radiation, i.e. X-ray equipment. So apart from natural sources of radiation, we also have artificial sources of radiation. And on site at EI Electronics, we have X-ray machines. And artificial sources of radiation are sources of radiation that are not naturally occurring, i.e. that are manufactured. So these X-ray machines that we have on site at EI Electronics are all manufactured pieces of electronic equipment. And this X-ray equipment all have X-ray tubes in it, and those, when they're switched on, will produce X-rays, which are a form of ionizing radiation. Also on site at EI Electronics in the past, we did produce smoke detectors called ionization chamber smoke detectors that had a small radioactive source in them called americium-241. These smoke detectors have now been discontinued, so we are no longer producing or manufacturing these on site. So the only form of sources of ionizing radiation that we have on site now are X-ray machines that have X-ray tubes inside them. We have different types of X-ray equipment on site at EI Electronics. And here they are used for quality control and non-destructive testing of components on site. So we have different X-ray machines that are used for testing of components and quality control purposes. All X-ray machines have an X-ray tube inside it. And the way an X-ray tube works is you have a power supply going into the X-ray tube. There's a filament here in the tube, a little bit like the filament in a tungsten light bulb. When the power to the tube is switched on, this filament heats up and it boils off electrons. And a voltage is applied here, and that causes these electrons to accelerate or to speed up. They hit off a target inside the tube, and then they generate these X-rays. So the X-rays are electrically produced. The important thing to remember about X-ray machines is that if we don't want these X-rays anymore, all we have to do is stop the current from flowing, so turn off the power to the X-ray tube. And once the power is switched off, we don't get this flow of electrons anymore, so they never hit the target and we never get these X-rays generated. So in terms of hazard and safety, they are a very safe form of ionizing radiation because they can be easily switched on and off. And when we don't want them anymore, all we have to do is turn off the power to the X-ray tube. So again, in an X-ray tube, when a current flows from one end of the tube to the other, the electrons hit a target and X-rays are generated. And X-rays can be easily switched on and off as they are electrically produced. Types of X-ray equipment at EI Electronics. Well, currently we have 3 cabinet X-ray machines on site at EI Electronics. We have a Glenbrook Technologies DualBox 70T machine. We have a Zeiss Metrotom 1 cabinet X-ray machine, and we have a Unicomp Technology LX2000 machine. So there are 3 X-ray machines on site. And these are termed cabinet X-ray machines because the X-ray tube is completely enclosed inside an outer cabinet that is designed to protect the operator from the X-rays when they are being emitted. So they're very safe machines, and they are the safest form of ionizing radiation really that you could work with. There are many safety features that we will find on X-ray machines. And some of these safety features will include the following: a power on light, so a light that tells us when the actual power is onto the equipment. And more importantly, an X-ray on light, so that we know when the X-rays are actually on or off. So we can see here the various pieces of equipment that we have on site. The Glenbrook Technologies here, we have an orange X-ray on light. On the Zeiss Metrotom, we have this orange X-ray on light here as well. And on the Unicomp Technology, there is a red warning light that comes on to tell us when the X-rays are actually on. So it's important that, depending on which machine we're using, we understand the significance of the various warning lights, what they mean, and where those lights are on the machine, and that we know whether the machine is in hazard mode or not, is actually producing X-rays or not. There should also be a means of switching off the x-rays quickly in an emergency. So generally we will have an emergency stop button on x-ray machines. This could be on the machine itself, or it could be on the actual operator's console. So we can see here the red e-stop button, and if you press that e-stop, it will immediately switch off the x-rays and render the machine in a safe condition. And on the Glenbrook Technologies one, we just simply have a red power off button that will switch off the x-rays for you. All machines are also key operated, so you must have the key in place to operate the machine, and if the key is taken out, the machine can't be switched on. So again, we can see the keys in place here in the consoles on the various machines, and it's important that those keys are taken out as well when the machines are not in use, and that they're kept somewhere safe, so generally in a secure lockbox near the machine. Machines are also generally password protected, so the operator has to log on to a computer system and put in their user password to be able to operate the machine. So all of these controls ensure that only authorized and trained persons can use the equipment, and that the machine is used in a safe manner. Other safety features on x-ray machines that we have on site at EI Electronics include shielding. So all of these x-ray machines have lead cabinets and leaded doors or leaded glass windows in them. So the lead is there as a shield. It protects the operator from the x-rays. When the x-rays are produced inside the machine, they can't get to the external area outside the machine because we've got thick lead panels inside the interior of the cabinets, and that protects the operator from the x-rays when they're operating the machine. So you can see the cabinet here, it's got thick lead all around it. Any doors are made of leaded glass, and any viewing panels are made of leaded glass, so the x-rays can't escape. And again here we can see the lead cabinet, the lead lined door, and any hatches that allow product to go in and out are also made of lead, and they must be closed when the x-rays are on. We must have adequate warning signage in place on all the equipment to warn people of the presence of x-rays. So again, on all the machines you can see that there are warning signs to tell us that there are x-rays being produced, and do not insert any part of the body when the x-ray is energized. And again, on the Unicomp machine we can see the radiation ionizing radiation hazard warning sign there, and also on the Zeiss machine there will be warning signs on all of these machines. The machines are designed to restrict access to what we call the primary X-ray beam, the main X-ray beam that is produced inside in the machine. So we can't get access to that beam when the X-rays are on. All of these doors are interlocked with the beam. So if I try to open this door when the X-ray beam is on, I will not be able to open the door when the beam is on, or if I open the door, the beam will automatically cut off, so I can't get access to the X-ray beam when it is on. And you can see here again interlocks on all of these doors. So if you open the doors and carefully examine them, you will see inside that there are interlocks on the doors, and that ensures that the machines are intrinsically safe and that you cannot get access to the X-ray beam when the beam is on. And the principles of time, distance and shielding are always taken into account in design factors. So these are the three key principles of protection from X-rays. We limit our time beside the X-ray, we keep our distance from the X-ray, and we ensure that there is adequate shielding in place. So with X-ray equipment we can spend as much time as we want beside them because the lead shielding is protecting us from the X-rays all the time. So we can spend all day every day working beside them, we're not getting any radiation exposure. We do have to keep our distance from the X-ray beam itself, but the design of the machine ensures that that occurs. So again, because of these interlocked doors and closed hatches, we can't actually get access to the beam, so we're kept at a distance from it. And shielding, all of the machines have this lead shielding and lead cabinets built into them to protect us from the X-rays. Safety rules that you should be aware of when operating X-ray machines. So always ensure the X-ray is off before accessing the interior of the cabinet. So if you have to open the door of the cabinet to put a sample in or take a sample out, or to clean the inside of the cabinet or to maintain it, just always check that the X-ray on light is actually off before you do that. And again, the machine should do this for you, keep you intrinsically safe, because the door cannot be opened when the beam is on, but it's always a good idea to make sure that the X-ray on light is actually off when you open the door of the cabinet and before you access the interior of the cabinet. Report any damaged or faulty equipment, warning lights or shielding. So if you notice yourself that the equipment appears to be damaged in some way, if there's any cracks in the lead, if the warning lights aren't working, there's a bulb gone, or the shielding looks damaged in any way, please report it to your line manager so that it can be repaired and that a competent service engineer can have a look at it. Replace any missing, worn or illegible signage. So again, any warning signs that are on the machine that look worn away or can't be read anymore, these should be replaced. And always ensure that they are visible as well, so don't place other items in front of them so that they can't be seen. Ensure that the equipment is serviced and maintained. So all of these X-ray machines have to be serviced and maintained by competent persons at least once annually, and records must be maintained of that. And don't ever try to override any of the safety features or interlocks on the machine. They are there for your protection, so it's really important that we don't interfere with them. There are a number of legal requirements that EI Electronics has to comply with in order to have X-ray equipment on site. Firstly, we need to have a license from the Environmental Protection Agency, the EPA. So this EPA license must be in place, and we have a license in place from the EPA. The EPA license must be displayed on site as well, so you may notice a copy of this license displayed beside the X-ray equipment, and that's a legal requirement that we have this EPA license displayed on site. We must have a radiation protection officer appointed. They're called an RPO. So somebody on site has to be the nominated and trained RPO, and that person looks after radiation protection matters on a day-to-day basis and ensures we comply with the conditions in our EPA license. We must also have a radiation protection advisor, an RPA, engaged for ongoing consultation and advice. And that's myself, Dr. Elaine Dorley. I am the approved radiation protection advisor for EI Electronics, and I come in once annually and do a site visit and compliance assessment and ensure that everything is compliant. All equipment must be serviced and maintained as per manufacturer's instructions, and we must keep evidence of service reports and maintenance reports on file for inspection by the Environmental Protection Agency. There's a legal requirement for training of persons, and that's one of the reasons we're doing this training course, is that all persons who work with X-ray equipment on site must have radiation safety awareness training. Audits and inspections are undertaken, so the Radiation Protection Officer, the RPO on site, will do their own safety inspections. The Radiation Protection Advisor will come to site once a year and do a full radiation safety audit, and you're also subject to inspection by the Environmental Protection Agency, and they do come on site every now and again and do their own inspections. And radiation dose rate surveys are carried out regularly. So this is when we use a radiation monitor to check the radiation levels around the X-ray machines and ensure that all is in order. There are legal radiation dose limits that we have to ensure we comply with, and we check the radiation levels around the X-ray machines using monitors such as this. These are called radiation dose rate meters or radiation monitors. And regular checks are undertaken by both the Radiation Protection Officer, the service engineers for the X-ray equipment, and also the radiation protection advisor on annual audits on site. And we have never found radiation levels to be any greater than background radiation levels in the operator's working position. So we're always getting some dose of radiation that's from natural background radiation, but we can't detect anything greater than that when people are working beside the X-ray machine. So they're very, very safe for people to work with. There are legal limits that we have to ensure we don't exceed. The dose limit that should not be exceeded is 1 millisievert per year. We've never had any difficulty in ensuring we comply with this dose limit. And around the shielded X-ray cabinet itself, we have to ensure that the dose rate is never greater than 1 microsievert per hour. So here we can see a background reading of 0.08 microsieverts per hour. If we were getting a reading of more than 1 microsievert per hour around the X-ray machine, we would put that machine out of service. But that has never happened. We never get any readings above 1 microsievert per hour. And just for comparison, on a typical flight, we would receive about 5 microsieverts per hour from naturally occurring cosmic radiation. So a dose rate of 1 microsievert per hour is actually very low. We would be getting about 5 times that sitting on an airplane. But please be aware that the dose rate inside the cabinet directly in the line of the X-ray beam is very significant, and it could cause harm to your skin, for example a skin burn or damage to your skin. So you never want to have your hand directly in the line of the X-ray beam when the beam is on, but again the safety features on the machine should prevent this from happening in the first place. We do also have, as an extra protective measure, these dosimetry badges, they're called, attached to each of the X-ray machines. They are constantly monitoring the radiation levels, and the information on these badges is downloaded by the radiation protection officer into reports. And the reports always show that these badges receive no dose whatsoever. There are always 0 readings on the badges. And that is just proving to us that nobody working in the vicinity of the X-ray machine is getting any radiation dose whatsoever. So we don't have to have these by law, but they're just an extra protective measure we put in place for peace of mind of the operators and to ensure that we know that no operator is getting any radiation from working with the X-ray machine. A concern that often arises is with regard to pregnant employees working with X-ray equipment. In general, it is perfectly safe for persons who are pregnant to work with cabinet X-ray machines because there is no radiation dose at all external to the cabinet, and so the fetus or the pregnant employee are not getting any radiation dose whatsoever when working with the X-ray equipment. There is a legal dose limit of 1 millisievert that we have to ensure is not exceeded while someone is pregnant. The important thing really is that if you become pregnant, that you inform your supervisor or line manager at an early stage so that they can undertake a pregnant employee risk assessment. It's a legal requirement that a pregnant employee risk assessment is undertaken in the workplace when someone becomes pregnant to look at all potential hazards to the pregnancy. And that can include many things like working with chemicals, manual handling, for example, and working with ionizing radiation sources is a particular risk factor that has to be looked at during pregnancy. While working with cabinet X-ray machines, there are no particular precautions that will be needed, and as I said, it is perfectly safe for persons to work with cabinet X-ray machines, but you must inform your supervisor and a pregnant employee risk assessment must be undertaken. Some important notes to remember. When the X-ray is off, there is no radiation hazard. So again, the X-rays are electrically produced. Once you cut the power to the X-ray machine, there is no radiation hazard. There are no radioactive materials used in the production of the X-ray beam. So there's no radioactive source inside in the machine that's spontaneously producing radiation. It's literally like a light bulb that's being switched on and off, and when the power is on, you can see the light or the X-rays are being generated, but when the power is off, just like in a light bulb, the light just goes off, it's not there anymore, and the X-rays are off similarly. And the product that has been x-rayed is not radioactive. So when you put a component in to x-ray it, you can take that out and handle it perfectly safely. The inside of the machine does not become contaminated in any way. It's perfectly safe for people to clean and maintain the inside of the machine once the x-ray is switched off. And the products that are x-rayed are not radioactive in any way. And finally, we want to talk about radiation emergencies. So what type of emergencies could arise as a result of having X-ray machines on site? Well, potentially you could have loss or theft of an X-ray machine. That's highly unlikely at EI Electronics because the site is very secure. The areas in which we have the X-ray machines located all have restricted access to them. And the machines themselves are very large, cumbersome pieces of equipment and can't be stolen very easily or removed from the site. Potentially an interlock could fail. You could open the door to the X-ray machine and find that the X-ray on light is actually still on and the beam is still on. So again, it's unlikely that this would occur because the machines are serviced and maintained regularly and as needed, and all safety features are checked. The shielding could potentially be damaged, so again, keep an eye out for any damage to the lead cabinet, the leaded glass, or any cracks that might result in the cabinet itself, because that could cause X-rays to potentially escape. The safety features on the X-ray machine might not work properly. They should fail safe. So for example, if a warning light, if the bulb goes in it, it should actually prevent the X-rays from coming on, or if an interlock fails, we should not be able to actually turn the X-ray beam on itself. So they're very safe pieces of equipment. We could get a high radiation dose rate reading around the machine when the RPO is doing a survey, or the service engineer or the radiation protection advisor. If we get any reading greater than 1 microsievert per hour, we would put that machine out of service and to have a service engineer look at the machine and ensure that it is safe before putting it back into use. But if you have any safety concerns at all, or in any emergency involving an X-ray machine, you simply stop work and turn off the power. So that's the most important thing, to turn off the power to the machine. If there's no power going into the X-ray machine, then no X-rays are being produced, and therefore we have no hazard. It's also important to prevent others from using the equipment if we know that it's not safe to use. So take the key out of the equipment and put it somewhere safely, or give it to the radiation protection officer, and maybe put a warning sign on it that it's not to be used. And also contact your supervisor, the radiation protection officer, and the service agent in the event of any safety concerns with regard to the use of X-ray equipment on site. You have now completed the EI Electronics Radiation Safety Awareness Training course, and thank you for your time and attention.